Hello and welcome to chapter 1 of our lecture note discussion. In this chapter, I'm going to introduce you to statistics and we are going to look at the basic concept of what is statistics. We will also look at data and how we define data. Then we are going to look at how statistics is applied in different fields. Let's start with a quick introduction. What is statistics? Statistics basically is the science of learning from data. So we are looking at three keywords: the science, then learning, and then data. You see, in statistics, what we basically do is we use scientific approach to learn as much as we could from data. And then somebody will ask, what is data? Data is basically numerical fact about element, numerical fact about individuals. The important thing here is a lot of times you see people talk about statistics and they just throw some numbers around without using facts. If we are going to be able to learn from numbers, if we are going to be able to learn more about people or about individuals in an environment, we need to use facts because facts are better in decision making than ignorance. We cannot just pick any number from anywhere and use that to conclude about a certain group of people. And so, to be able to learn more about individuals, to be able to learn all that we could about elements, we need facts. And these facts are what we consider to be data. They are basically numbers that have certain circumstances or certain meanings to them. Without the context to data, the numbers will be meaningless. I'll give you an example here to explain a bit further. If I write the following numbers down: 3, 4, 5, 6, and then maybe say 1. Without the context, without certain circumstances surrounding these numbers, it becomes difficult for you to understand. And so these numbers could be factual, these numbers could be data representing a group of individuals or a group of elements. Without a context to it, it will make sense. And so we need a context to understand what these numbers basically are. Now, somebody will say, I don't really need statistics. I don't think statistics is important for me. You see, statistics is applicable in many situations. Your decision to take this course at this time of the year could be based on certain statistics that you performed. Maybe you observed that taking an online statistics course with CNC gives you a much better chance of achieving a certain goal, and that is why you decided to take the course. And so, statistics is applicable in many different fields of life. The accountant needs statistics to be able to infer on a company's performance and make a good judgment call on whether the company is doing well or not. Financial advisors use statistics to make investment recommendations to their client. And so they study the statistics of how a company is performing and then they make recommendations whether their clients should invest in the company. The marketing executive used statistics to establish a relationship between promotion activities and sales. And so a marketing executive will look at whether or not a certain promotion activity results in sales by studying the statistics of previous activities. In production, in economics, in information systems, we apply statistics to be able to make judgment calls. However, to be able to make the right recommendation as an accountant, to be able to make the right recommendation, investment decision, to be able to make the right analysis, we need data. So, circling back to what we talked about earlier, data are basically facts. They are facts and figures that are, first of all, collected, analyzed, and summarized for presentation and interpretation. And so that's exactly what we will be gonna do. We will be doing in this course. We are gonna learn how to first of all collect data, analyze data, and then summarize data for presentations and interpretation. But to be able to collect this numerical fact, we need first of all to know what we call element or individuals. What is an element or what is an individual? Elements or individuals are basically the object of interest to us. Individuals are the object that we want to study about. And this object has numerical fact that presents itself in a set of data. Now, elements or individuals could be people, they could be animals, or they could be non-living objects. And so in statistics, our main interest is to know more about people. In some cases, we just want to know more about animal groups or other living things, or we just want to know more about objects. And so let me take, for example, what a group of people could be like. Let's say I want to study a bit more about students at CNC. And so in this case, the element or the individual of interest to me in my study are the student or the people. So the people could be students, it could be residents in a certain locality, it could even be the number of students taking a course like Math 157 in a class. We could also consider individuals to be animals. In most cases, what most scientists do is before they introduce a treatment into the human environment, they test them on animals. And so we could decide to study the behavior of animals, and in this case, animals could be the element of interest. Or we could just be interested in studying objects. It could be cars. The object of interest could be laptops. And so in statistics, we first need to identify the individual or the element of interest. The next thing we do in statistics is to consider what we call a variable. We define variable as any characteristic of interest for an element or an individual. And so let's take, for example, for a specific statistical study, we are interested in people. Now, people or human beings have different variables. They have different characteristics that could be of interest to us. For example, we may be interested in studying the height of the individuals, or we could be interested in studying the age of individuals. We might be interested in studying their shoe sizes. In the case of students, we may be interested in studying their marks distribution for a course. Or we could be interested in studying their hours of study. And so, trying to tie everything in statistics, we are interested in people or element or individuals. But for every individual that we want to study, we take a specific variable of interest or a characteristic of interest, and we try to study how the distribution of that variable is for different individuals in our study. Now, it's interesting to know that variables come in different forms, and we'll talk a little bit about that, but the values of a variable can be different for different elements. Let's take, for example, I go into a preschool of little kids, and I want to study the ages of the individuals there. And so here, my individual, the element of study is preschoolers. The variable of interest could be the ages. What is their age distribution? And so I go into a preschool and then I ask the instructor permission to study the kids, and so then I have the kids line up, and then I create a table like this where I have ages, which is a variable of interest, and I start collecting values in terms of the age distribution of these kids. So let's take, for example, 5 kids in a preschool decide to participate in the study. I ask the preschooler I ask the instructor to give me their ages, and then the instructor gives me the following ages: 3, 3, maybe 4, 4, and then 3. In statistics, this is what we are interested in. The individuals are the preschoolers. The variable of interest, the characteristic of interest is the ages. We could decide to study different variables. Maybe we are not interested in the ages. We could be interested in something like their weight or their height, or it could be their favorite color or their favorite food, right? And so for all individuals, we pick a variable of interest and we collect numbers on that. Now, the collection of facts, the collection of data for a specific variable is what we call a data set. And so up here we have the variable, and for each variable we collect a data set. Now, the combination of a variable and the data set gives us what we call a distribution. And so when we talk about a distribution, we are looking at the variable plus the data set. But to be able to consider a variable of interest, you need what we call context. What is the purpose for the variable? Why are we collecting numbers on this variable? Why is the variable an interesting variable to us? What kind of element, what kind of individuals are described by the variable, and how many variables are we gonna collect? You see, you need to have a reason. You need to have an explanation for why you're collecting these data set on a specific variable. And that is what provides it the context. Now, it's important to note that all variables have unit of measurement. And so going back to our example on the preschool study, where we go into a preschool and then we collect data set on a specific variable of interest, it's important to know that whatever the variable of interest is, we should have a unit of measurement for them. For example, if at the preschool I'm trying to study the height of the preschoolers, then I should have a unit of measurement as in like feet or inches or maybe meters or centimeters. And this could be the unit of measurement to use. For every variable that we identify, we need to have their unit of measurement. If, let's say, I'm studying the income of a company or a country, we can use the per capita income. Or if I'm trying to study the weight of preschoolers, I can measure the weight in kilograms or grams or pounds, right? And so different units of measurement can be used to describe the variable of interest. If I'm measuring height, I can do it in feet as well, inches, and the others. If I'm measuring other stuff like speed, right, there should be a unit measurement on that. If I'm measuring something else like ages, I should have to describe the unit of measurement to use to describe that. And so for every distribution, we have the variable at the top, and then we collect the data set on it. For example, if I'm looking at favorite foods, I could go into a preschool and ask the children to give me favorite foods. And so somebody will say, hey, I'm sorry, I'm gonna go with something as simple as favorite colors. Right? So somebody will say, I love the color pink, I love blue, I love red. Another guy may say blue, and then maybe I'll have another blue here. And so here we have a variable, which is a favorite color. We have the data set, which is the the different values for that variable. Together, these two gives us the distribution. But there's one more thing. Each value here is considered an observation. And so here we have observation 1, we have observation 2, we have observation 3, observation 4, observation 5. And so each value in our data set, or each value obtained for a particular element in our distribution, is what we consider as an observation. Now, we can also put our measurement for the variables into what we call scales. A certain variable could be described as a nominal, which means it just consists of labels or names that are used to identify the variable. There are no arrangement to it. There are no differentiation in terms of the weight or the how much they carry. Or a variable could be described as ordinal, which means they are nominal, but they have certain rank or order to it. Other variables could be considered as interval. An interval variable basically consists of ordinal data, but it ranges between an interval of a lower value or a higher value. Now, interval values variables are always numerical, and we'll spend a little bit of time to talk about what we mean by numerical or non-numerical variables. And another scale of measurement for variables is what we call ratio. Ratio variables basically consist of interval data, but with a ratio of two values attached to it. So let's look at an example of the different scales of measurement. Let's say we go into a company, and at a company we are looking at different variables for different observation. So we talk to the first person and we say, okay, what is your department? And the person says, my department is accounting. How much do you make in an interval of two numbers for your income? And the person says, I make between 10K and 12K. What is your position here? Person's position may be a senior, and the height of that person could be 6.3. And so in this study here, you could see that we have a data set. We are looking at individuals, and in terms of the individuals, we are looking at the variables. So one variable could be the department the person belongs to. So here we have variable 1, variable 2, variable 3, and then variable 4. And for each of these variables, we have our data set. And so for the department variable, this is our data set. For the income variable, this is our data set. For the position variable, this is our data set. And then for the height variable, this is our data set. Together, the variable and the data set gives us what we call a distribution. And so this is the distribution of department. This is the distribution of income. This is the distribution of position. Here we have the distribution of height. Now, for each person observed, this is observation 1, observation 2, observation 3, and observation 4. What we are looking at in terms of the scale of measurement is when you take a variable like department, what kind of measurement are we looking at? And we can say department basically is a nominal scale of measurement. Why? Because accounting is not bigger than finance. Finance is not bigger than marketing. And so what we are looking at here is we are putting just labels where there is no differentiation in terms of rank or order. But when you look at another variable like the income variable here, you will notice that the values of this variable ranges between two numbers, and that makes it interval scale of measurement. Position, on the other hand, gives us values that can be ranked. And so the senior position is ranked higher than the junior. A junior position could be ranked higher than the seasonal or part-time. A part-time position could be ranked higher than the seasonal. And so here we have labels, but we have attached a certain level of rank to them. And the last variable that we are looking at in terms of the scale of measurement is the height. We're saying the height variable follows a ratio variable in a sense that it's numerical, it's just numbers, but with a ratio or a floating point value attached to them. And so when it comes to scale of measurement, the ones that are only variable values but with a floating point or decimal point value attached to them are considered to be ratio. The one that are just labels but with a certain rank to them or a certain order to them are called ordinal. Those that ranges between two values are considered to be interval, and those that are just labels are considered to be nominal labels. Now, another thing we can also do when it comes to variables is we can categorize variables into two types. A variable could be categorical or quantitative. Now, another name for categorical variable is qualitative variables. So we can either call them categorical or qualitative variables. And another name for quantitative variables is numerical variables. So you can either say categorical or qualitative, or you can say numerical or quantitative. What is the difference between categorical and numerical variables? Categorical variables basically are variables that take values that places an individual into one or several groups. Numerical variables, on the other hand, take numerical values upon which we can perform arithmetic operations such as adding and averaging. Let me be a bit clearer. For categorical variables, we are looking at variables that take values upon which we cannot perform arithmetic operations on. Let's look at some examples of variables that are considered to be categorical. For example, favorite color. When I take favorite color as a variable and I ask you to give me your favorite colors, the numbers you might give me could be, or the values that you could supply for favorite colors could be red, green, blue, and so on and so forth. Now, if you look at the values of this variable favorite color, you will agree that I cannot perform arithmetic operation on this. I cannot perform addition, subtraction, division, or multiplication on any of these variables. But let's consider quantitative variables as an example. And let's choose a variable of interest like age. If I ask a group of students to supply their ages for a study, I may get some ages like 20 years, 22 years, 35 years, maybe 60 years, right? And you will agree that when I consider the data set or the values supplied for the values collected for this variable age here, I can perform arithmetic operations on them. I can subtract or I can find the difference between the highest value and the smallest value. I can multiply the first two values. I can divide the highest value by the smallest value. And so all variables that we can perform arithmetic operations on are considered quantitative or numerical. For those that we cannot perform arithmetic operations on, we consider them to be qualitative or categorical. Now, whenever you are confused, look at the names. Qualitative because we are dealing in quality. Quantitative because we are dealing in quantity. Right. Please take note for the purpose of your first assignment. I may give you a list of variables and ask you to categorize them into categorical or quantitative. And so again, don't forget the combination of the variable and the data set for that variable gives us what we call a distribution. And so the distribution of a variable tells us what value it is and how often those values are repeated. And so, for example, let's backtracking a little bit here. If I take a variable of interest like income, income per hour, how much do you make every hour? I can have values like $30, $29, $15. Okay, that could be a little bit below the minimum wage, but that's fine. $20 an hour or $45 an hour. And so this is the data set. This is the variable. Together, they give us what we call a distribution. So let's look at some examples, and I want you to pause the video here and list down some variable of interest. So I want you to list down some variable of interest. Oh, sorry about that. List down some variable of interest, some variables of interest, and I want you to practice categorizing them either as categorical or quantitative. Again, remember, another name for categorical is qualitative variable. Another name for quantitative variables is what we call numerical variables. All right, so how did your exercise go? Were you able to categorize them as categorical and quantitative? Perfect. Okay, now let's continue to section 1.3. Here, the big question is data source. Where do we get the data from? Remember, we said statistics is the science of learning from data, the science of knowing more about a group of people, individuals, elements. But to be able to know more about these people, or to be able to know more about these animals or other objects, we need to be able to collect values on that. And so we look at a paper, we take a variable of interest, and then we collect values on that variable of interest. But the big question is, where do we get the values from? There are two main sources of data. It could be primary source or an existing source. Primary source basically is where you go out there to collect the data yourself. And so in primary source of data collection, we usually create surveys or we create questionnaires. And then we present the survey and questionnaires to the people or to the individual of interest or to those that are working with these individuals of interest. They fill out the forms and then we analyze the data from there. And so I could walk into a class here at CNC and then with the teacher's permission and of course the student's permission, I could collect as a primary source of data collection values on their age, address, telephone numbers, and other stuff that may be of interest to my study. Now, another source of data collection is what we call existing source. Now, in some books, they will classify existing source also as secondary source of data collection. And so we either call it existing sources or secondary source. And this is basically where you look at data that has already been collected for different purposes but could be used for your study. And so I can walk into a company and with the company's permission, collect internal records on sales, advertising, expenditure, production, or inventory. Or I can go into an industry association like the trade union, or maybe say over here in BC, I can walk into WorkSafe or WorkBC and ask them to provide data for a very specific variable of interest. Another source of existing sources maybe go on the internet. You look at government website, non-profit organizations like World Health Organization for those that are in the medical program, and collect existing source of data from there. Now, once we collect the data, and that is where it comes in, how do we collect the data? If I decide to go into a primary source of data collection where I actually participate in the data collection in its raw state, how do I do it? It could be either I perform what we call an observational study or an experiment. And again, for the purpose of your first mate assignment, know the difference between an observational study and an experiment. And so, what is an observational study? In an observational study, what we are basically doing as a primary source of data collection is where we only observe the individual in their natural habitat and record our observation. In an observational study, we do not impose any form of treatment on the subject or the participant. An experiment, however, is where we impose a certain condition on the participant or the individual, and then we record their reaction to it in a controlled condition. Let's look at some examples of observational study and then some examples of an experiment. So if I if I get into a school and I observe hours of study as a variable of interest, if I observe how many hours students are studying in their natural environment, very important, in their natural environment without imposing any treatment, any condition on them. The students are in their natural environment studying, and so all I do is observe and record how many hours they study. That is an observational study. I don't interfere in any way. The students are in their natural environment doing their own thing like they do every time. That is an observational study. An experiment, however, could be me asking the student to come to a place or to a room and requiring them to study for a certain hours. That is an experiment. And so in an observational study, here the person is doing things that they usually do in their own time, following their own way of life. In an experiment, I impose a condition on them. Another experiment. If I go to the playground and observe little kids playing at the playground, doing their own stuff, and I record how they feel about the different kind of activities that they do at the playground, that is an observational study. An experiment, on the other hand, could be me taking the kids to a controlled environment, like a controlled playground, and asking the kids to participate in certain activity and in recording their response to the different activities at the playground. And so, in an observational study, one, the individual is in their natural environment. Two, the individual is doing something that they usually love to do or the way they want to do it. And three, I only observe and record. Sorry. In an experiment, on the other hand, I impose certain condition on the person. And the condition could be moving the person to a different environment. The condition could be giving the person something to take in. The condition could be imposing certain condition on the person. And so an observational study is where the person do stuff and I only observe and record. But an experiment is where I impose a condition on them. Let me quickly share a story here. Some time ago in Prince George, I was part of a study where we wanted to know how people behave or how people spend when they are using their own source of finance versus when they are giving money. And so in this study, what we did was we asked the participants, and I think we took about 100 participants. And what we asked the 100 participants to do was we, in the first case, gave each and every one of them $100, and we asked them to go out there and shop. Now, because we gave them the money and then we asked them to go and shop and observe what they were buying with that $100 each, that is an experiment. An observational study is where the individuals could be asked, or we could just quietly observe the individuals shopping on their own and only recording what they are buying. And so, in an observational study, the individual is in their natural habitat, using their own resource, buying whatever they want to buy without knowing that we are observing and recording. But in an experiment, we impose a condition on them. Now, it's important to note that when it comes to data collection, there could be some issues here. And that's why a lot of people, instead of using primary sources, tend to use existing sources. Primary source could cost you time, and it also costs you in terms of finances. With primary sources, you have to be careful because you need to make sure that your data is collected well. And so there are different things that comes into play when it comes to primary source of data collection. Okay, I'm gonna wrap up here for the first part of the lecture note. When we get back again, we are gonna discuss section 1.4. We're gonna start from section 1.4, which is descriptive statistics. Thank you for joining me and see you in the next lecture video.